Once the mu receptor has been internalized, there are numerous different intracellular pathways or cascades that it may partake in. So it would be incorrect to think once the mu receptor has become internalized in this endosome that it is no longer functionally or biologically active. Indeed, there's significant evidence showing that the signaling that can take place within this structure with the more agonist bound can have even bigger effects than potentially the um, effects that happen at the surface. MAPK ERK signaling is one example of this, which will be talked about later. Here, I just want to focus on the PKC phosphorylation that can occur. Um, the importance of this step really is because it can drive the internalized mu receptor into a state, a resensitized state. So one that perhaps loses the initial phosphorylation that was initially introduced by GRK2 and 3, and is also then trafficked back to the surface, such that when this receptor comes into contact with a more agonist like fentanyl, it will be able to respond and uh, drive intracellular signaling such that analgesia, euphoria, um, etc. will be produced. So although one approach is to try and prevent its internalization and desensitization in the first place, another way of looking at it is if we can increase the rate at which internalized receptors are resensitized and reintroduced to the surface, we can also prevent tolerance from developing um, in the first place. So evidence shows that PKC being activated by PLC, which is in turn driven by the G protein A cascade, can increase the rate of recycling. So increase this transition from internalized endosomal mu receptor to externalized and resensitized mu receptor. Therefore, PKC activators hold promise as pharmacological agents that could prevent tolerance from developing in the first place, and therefore could be used as opioid adjuncts.